Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0651-A1 indicates a malfunction in the sensor reference voltage 2 circuit. This issue arises when the power supply for the sensor falls outside a specified operational range, prompting the Transmission Control Module, TCM, to recognize an abnormality and subsequently store the code. The TCM is essentially the computer that manages the transmission's operation and relies on data from various sensors to make precise adjustments for optimal performance. In this case, the reference voltage of the second sensor, vital for transmitting accurate data to the TCM, is compromised. Affected components include the torque converter turbine speed sensor and the continuously variable transmission CVT speed sensor, which are crucial for measuring the speed and performance of the vehicle's transmission system. These sensors can be located on or near the transmission housing and typically have wires connected to them that provide power and data back to the TCM. The DTC P0651 specifically points to a malfunction within the sensor circuit responsible for the reference voltage used by the TCM. The TCM, or Transmission Control Module, utilizes various sensor data to make operational decisions, especially in regards to transmission fluid application or gear shifting. Should the voltage supply deviate from expected parameters, sensor readings may become unreliable. This can lead to poor vehicle performance, irregular shifting, or even failure to shift at all. The sensors affected include VCC2 and VCC3, which are the power supplies linked to the torque converter turbine speed sensor and the CVT speed sensor. These components are crucial as they help to monitor the speed of the transmission and ensure it functions smoothly. Without accurate voltage, the TCM cannot perform effectively, which may trigger additional diagnostic trouble codes. Several potential causes can lead to DTC P0651 being triggered. One common issue is shorted wiring, particularly in the VCC2 or VCC3 lines. Shorts can occur due to wear, abrasion, or exposure to elements, disrupting the flow of voltage to sensors. Additionally, a faulty TCM can also bring about this DTC, as the module itself may be unable to process signals accurately if it's malfunctioning. Damaged sensor connections are another possible cause. If the connectors to the torque converter or CVT speed sensor are corroded or pulled loose, they will fail to provide an adequate power supply. Environmental factors like moisture can also contribute to electrical faults. Lastly, incorrect installation during maintenance can lead to unintended wiring issues, resulting in a failure to relay the correct voltage to the respective sensors. The symptoms associated with DTC P0651 can significantly impact the vehicle's drivability. One prevalent symptom is erratic shifting. Drivers may experience harsh or unexpected gear changes. This is due to the TCM's inability to accurately interpret data, leading to improper shifting decisions. Additionally, overall transmission performance may suffer, causing sluggish acceleration or difficulty in maintaining speed. You may also notice a lack of response or delayed engagement when attempting to shift gears. This can be concerning and may lead to further complications if not addressed promptly. Most importantly, the DTC will be displayed in the vehicle's diagnostic system, prompting the need for further inspection and troubleshooting to ensure the transmission operates smoothly. The first troubleshooting step for DTC P0651 involves preparing the vehicle for inspection. Start by turning the ignition to the on position without starting the engine. This action allows you to access the vehicle's onboard diagnostics and check for any DTCs that are currently stored or pending. Pay particular attention to the signals being relayed by the TCM as monitoring these can give insights into how the vehicle is reacting to input. Confirm that the TCM is receiving proper voltage levels, focusing on VCC2 and VCC3 lines. Any irregularities at this stage can indicate the initial points where the malfunction may exist. Following this, documentation of any additional DTCs may help in pinpointing both immediate and related issues that may also need attention. The second troubleshooting step involves a physical inspection of the TCM and associated sensors. Begin with disconnecting the TCM connector and visually checking for any signs of damaged wires or corrosion. Next, inspect the connections to the CVT speed sensor and the torque converter turbine speed sensor. Look for loose wires, shorts, or any wear that might cause an interruption in the voltage supply. It's crucial to perform these inspections methodically to ensure no components are overlooked. Any abnormalities found at this stage will likely require addressing through repair or replacement. If everything appears normal externally, it may necessitate further testing with specialized diagnostic tools to confirm the integrity of the circuit and connection points. In the third step of troubleshooting DTC P0651, you'll need to perform a thorough inspection of the wiring involved in the VCC2 and VCC3 lines. Disconnecting the relevant connectors allows you to get a clear view of the wiring in question. Using a multimeter, check for shorts to power and ground, as improper voltages can indicate breaks or shorts in the wiring. Testing should be done while the vehicle is in normal operating conditions. For example, having the ignition in the on position. If there are shorts or less than 1 megaohm of resistance found when checking the ground connections, this indicates a problem in the wiring that likely needs to be resolved. Document your findings meticulously. This data will inform the next steps in resolving the malfunction. After completing all necessary repairs, it's essential to reconnect all components properly. This includes the TCM connector and the connectors for both the CVT speed sensor and the torque converter turbine speed sensor. Once everything is reconnected, clear any stored DTCs from the TCM using the diagnostic tool, which will reset the system for further testing. Always follow this by taking the vehicle for a test drive under various conditions to ensure that the system is functioning as expected. Observing the performance during the drive can help identify whether the original problem has been resolved. Continuously monitor the vehicle's diagnostics for any reoccurring DTCs. If P0651 or any related codes appear again, further investigation will be required to address unresolved issues. Prevention is always better than cure, especially for issues related to DTC P0651. One of the best preventive maintenance methods is to conduct regular inspections of the vehicle's electrical components. Periodically checking the condition of wiring and connectors can reveal wear or corrosion before they lead to functional problems. Ensuring that connectors are clean and free of dirt or moisture is vital, as this can prevent potential shorts or bad connections. Additionally, maintaining proper vehicle servicing schedules can help catch issues early. Applying dielectric grease to connections may also help protect from moisture and corrosion. Lastly, educating yourself or the technicians that handle the vehicle on common issues related to voltage supply and sensor problems can keep the vehicle performing optimally. In summary, diagnosing and troubleshooting DTC P0651 involves a systematic approach, beginning with verifying ignition signals and inspecting the TCM and sensors for connectivity issues. The integrity of voltage supplies like VCC2 and VCC3 is essential for ensuring that the TCM can process the necessary data effectively. Addressing wiring faults, shorts, and ensuring clean connectors will greatly reduce the chances of recurrence of this DTC. Proactive maintenance, such as regular inspections, allows you to stay ahead of potential issues, ensuring the longevity and smooth operation of the vehicle. Always remember that keeping the transmission components properly functioning is crucial to maintaining overall vehicle performance. By adhering to recommended preventive strategies, you can avoid disruptive problems in the future. Please like and subscribe to the channel. See you next time.